Okay, good evening, Professor DavidJDelosReyes. Okay, it's Augustine 2023. The time is around 10:59 a.m. or almost 11 o'clock. Okay, my discussion for tonight will be a long video format discussion, and this is a topic on college algebra. Okay, let's proceed. So for those of you who are following my college algebra long form discussion, this is now lesson number 28. We are running smooth, okay? We are running smooth. Okay, let's proceed. The topic for tonight will be a long video format discussion, and this is college algebra lesson number 28. Okay. And the title of the topic will be Solution of Radical Equations. Radical equations. 26 and 27, lesson 26 and 27, we discuss what are radical expressions. And a radical expression is an expression that contains radicals. So at least we know what is a radical sign, a radicand, or the index of a radical. And since we know already a radical expression is just almost similar to the radical equation, except that the radical expression don't have an equality sign. And for a radical equation, okay, there will be an equality sign, and the right hand side should be, there is a value, it could either be 0 or some values. So a radical equation is a radical expression which has an equality sign. Okay, let's proceed. The solution of a radical equation is, it is just solving for the unknown variable x or y maybe, okay? But since it involves a radical sign, okay, at least we know how to, simplify this by using our knowledge of the so-called laws of exponents. Okay, I will give you example number 1. Example, solve the radical equation. We are given the radical equation. The square root of 6x plus 5 equal to the square root of 2x plus 10. We got a radical sign on the left hand side, we got a radical sign on the right hand side, and we got an equality sign. So we got a radical equation. Okay? And we got radical inside the radical expression. The first radicand is a linear equation 6x plus 5, and the right hand side, the value of the radicand is 2x plus 10. The problem is asking what will be the value of x. Okay, what will be the value of x? Okay, so it seems we are now on the discussion linear equation. This is also linear, but since there is a radical sign, it is considered to be a radical equation in which we are just lucky the terms inside are linear equation. Okay, let's proceed with the solution. This is a square root. This is a square root. And a square root can be written as, if we try to change the form of this, we eliminate for the meantime the radical sign. We use exponential representation. The square root of 6x plus 5 can be written as 6x plus 5 raised to 1. These two are similar. And for the right hand side, it is also, this is a square root, right? Like what I said from the previous discussion, if the index of the radical is not given, it is understood to be square root. It is understood that the value of the index is actually equal to 2. So for square root, okay, we don't write the value 2 on the index, right? But if it is a cube root, put 3 over there. If it's fourth root, just place 4. Since the given one is not, there is no given index, it is assumed to be, or it is actually a square root. Okay, let's proceed. This square root can be equal to this, and this square root can be equal to this. So to eliminate this exponent 1/2 for both the left and right, Okay? We try to square both sides. Why we try to square both sides? We try to square both sides because a 1/2 multiplied by 2, okay, we square it. We are talking of the exponent, and that will be 1. So actually, by squaring 1/2, we'll eliminate the fractional exponent. That's the purpose there, right? So squaring both sides, then we try to expand this one here raised to 1/2. You raise it again to the second power. These two here cancel with this. So what remains on the right will be 6x plus 5. And for the right hand side, 2x plus 10 raised to 1/2, raise that again to the second power. These two here cancel with this. Okay, so 1/2 times 2 is actually 1. So the exponent for both the left and right is actually 1 now, after this squaring. And this is now 6x plus 5 equal to 2x plus 10. So after this squaring, we are back to square 1. We are now given a linear equation in one unknown, right? So we call it easy money, right? So we know how to solve for the unknowns if we are giving a linear equation. So like we have passed by on our discussions, try to maintain the unknown on the left hand side and put all constants to the right. So what do we do? 6x, we put this to the left, minus 2x, equal to 10. We put this 5 to the right. This is 10 minus 5. 4x will be equal to 5. Dividing both sides of the equation by 5, x now will be 5/4. Okay? So actually there is no problem in the solution as you know your concepts from the previous fundamental operations. Okay? So the problem here is the fundamental operation. That's why we started with lesson number 1, fundamental operations. Addition, subtraction, division, multiplication. Okay? We passed by those already. So we are using it here. So the answer is x equal to 5/4. Let's check the validity of our answer. It's easy to check the validity of the answer. Okay? For me, I do it by parts. This is square root, this square root. So what will I do is that I will try to compute first 6x plus 5 separately. Okay? Separately, I will not put first the square root. Later on, I will put the square root. 6x plus 5, substituting values. 6 times 5/4 plus 5, 30/4 plus 5. This should be 30. Okay, and this is actually over 1. This has been coming out from our short videos, right? The butterfly method. 30 times 1 will be 30, 4 times 5 will be 20. The resulting denominator is 4. Okay, short video on how to simplify two fractions with different denominator. So what comes out is 50/4. And also, for the second one, I will not put the radical sign first. I will compute first for 2x plus 10. 2x plus 10 will be 2 times 5/4 plus 10. This should be 10/4 plus 10. Again, we are adding two fractions with different denominators. The denominator is actually 4 and 1. So what's been coming out from the short videos, and we are saturated with this. Okay. 10 times 1 will be 10. 4 times 10 will be 40. Okay. Butterfly method, right? The resulting denominator will be the product 4 times 1, this is 4. 10 plus 40 will be 50. So 2x plus 10 after the simplification will be 50/4. So I now know the value of 6x plus 5 and 2x plus 40. So this will now be the time that I will put it inside the radical sign. So this should be the square root of 50/4. Is it equal to the square root of 50/4? Actually, in here, we can stop now. Right? We can stop from here. Because they are actually equal, right? So our answer is correct. This is our correct. And if you try to simplify, it's the same. 50 is the product of 25 times 2 all over 4. Is it equal to the square root of 25 times 2 over 4? 25 is a perfect square, 4 is a perfect square, we bring it out. So this will be 5/2. What remains inside will be square root of 2. Right hand side. 5 is a perfect square, 4 is a perfect square, we could bring it out. So this will be 5 halves is square root of 2. So 5 halves is square root of 2 is actually 5 halves is square root of 2. It is true. Okay? Our answer is correct. As simple as that one, if you know your previous discussions from fundamental operations up to lesson number 26. Okay? I am not scolding you guys, I am just telling you the problem, because if you know your fundamental operations, there will be no problem over here. Okay, example number 2, I am not scolding you. Example number 2, solve the radical equation, a little bit complicated. The square root of x plus 19 minus the square root of x plus 28 equal to minus 1. Or it is more complicated than example number 1. Okay, let's try to bring out the solution. I will rewrite the given radical equation. Okay, I will maintain this square root of x plus 19 to the left. This is negative, I will put it to the right, so this will now be the square root of x plus 28 minus 1. Okay, and again, to compute for x, we must have to eliminate the radical side. Okay, so we will take the square of both sides. Okay, meaning to say, you pinch this one with the bracket and you try to square both sides. It is this. If I will try to rewrite the square root of x plus 19, it can be written as x plus 19 raised to the 1 half. Raise that again to the second power. So if I will try to square the left hand side, these two here will vanish, right? It will cancel out. So what will come out on the right hand side will just be simply x plus 19, right? And for the right hand side, it is a binomial, right? It seems like we are having an a minus b quantity square, in which we pass by the so-called special products in factoring. Okay, this will now be expansion. It will be the square of the first one minus twice the product of these two, ab plus b square, in which the value of a is this radical here, and the value of b is this one here. So if we try to square the right hand side, the square of the square root of x plus 28, okay, the power 1 half will disappear, right? So what will remain will just be simply x plus 28. The middle term will be the product of the first and second, okay, times 2. But it should be negative because this is minus. So this is minus 2 times 1 times the square root of x plus 28. Or just simply minus 2 the square root of x plus 28. And the last part, we are following this, right? The square of minus 1, it is plus 1. Okay, combining similar terms, x plus 19, x plus 28 plus 1 is 29. Right? So what remains is, what do you call this? Try to, what do you call this, transpose all x terms to the left, okay? And try to maintain the radical sign on the right. So this is x. I will transpose this one, this minus x, plus 19. I will transpose this to the left, this minus 29. What remains on the right will be minus 2, the square root of x plus 28. And luckily, this x here cancel with this. And 19 minus 29 is minus 10, equal to minus 2, this 2 times the square root of x plus 28. Then you try to multiply this by minus 1 half. Right? Minus 10 times minus 1 half will be a positive 5. A negative times a negative will be positive. And a negative 2 times negative 1 half, it will now be plus, but these two here cancel with this. So what remains on the right will be the square root of x plus 28. And still, after the simplification of the squaring, okay, there is still a radical sign. So this is still considered a radical equation. And again, to remove the radical sign, the enemy of the power 1 half is actually 2, right? So we must have to square both sides. So it will be 5 times the quantity x plus 28. This square root can be written as x plus 28 raised to the 1 half. Okay, raise that again to the second power. The enemy of 1 half is 2 for it to become 1, right? So 5 squared will be 25. And x plus 28 raised to the 1 half. Raise that again to the second power. These two here cancel with it. So this will now be 25 equal to x plus 28. So after the squaring, we are now given a linear equation in one unknown, and we pass by the solution of a linear equation in one unknown, right? So transpose all the unknown terms to the left, all constants to the right. So this will now be x. After the rearranging, we'll transpose this 28 to the other side. So this should be 25 minus 28. X now will be a negative 3. Okay. Let's check the validity of our answer. We will try to compute for the value of x plus 19. Okay. We'll just do it orally. Minus 3 plus 19 will be 16. And the square root of 16 is 4. Either plus or minus 4. But we'll consider for the meantime positive 4. The value of the square root of x plus 28, a minus 3 plus 28 will be 25. And the square root of 25 is either plus or minus 5. We will use plus 5. So going back to this given original radical equation, the square root of x plus 19 is positive 4. And the square root of x plus 28 is 5. Minus 5. The operation is minus. Is it equal to minus 1? And minus 1 is equal to minus 1? It is true. Minus 1 equal to minus 1, it means our answer is correct. As simple as that one. Okay? If you try to use the negative side, it will not be an equality. We will disregard the value of, okay, on the simplification of the radical sign. We will just use the positive sign. Okay, that's it, guys. So for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. Okay, I will be telling this one, okay, try to watch my long video format discussions on college algebra. I am assuring you, you will learn something from it. Okay, a good evening from Los Angeles, Professor David J. Delos Reyes.